Okay, so we're going to go over quartile ranges and kind of how to separate it, and maybe even if we get a chance, box and scatter plots. But okay, first things first. To set up an interquartile range, we do want to know how many numbers or sets, pieces of data we have. So 1, 2. So we have 9 pieces of data here. And we also want to always set them up from lowest to greatest, okay? So the lowest term here, I think, is the number 3. And I'm going to scratch them out as I go just so it helps me keep track, okay? Because we don't want to duplicate what we've done. 3, 4, 5. Looks like we have 2 6s, okay? An 8, a 9, 11, and 15, right? Is that 9? Perfect, 9. Okay. Now, the easiest way to set up quartile ranges is quartiles are essentially broken into 4 pieces. Okay? So this, all of these quartiles together, is all of our data. Okay? And this represents quartile. So we have our first quartile from the end of quartile 1. So everything to the left of this would be quartile 1. It's 1. I've only broken this into 3. I was wondering why it looks odd. Sorry. There you go. Everything to the left of that would be quartile 1. Quartile 2 is everything in between. Quartile 3, and then quartile 4. Okay? So from the beginning, which is over here when we line it up from the lowest to the highest, okay? I guess we'll put those numbers down. So we have our lowest to our highest. The quartile 2 is actually considered our median. Okay, it's our middle number, which makes sense. Quartile 2, we have 1, 2 to the left of it and 1, 2 to the right of it. So in other words, that's the median, the middle number. So we need to figure out what a middle number is. And the best way to kind of get a good idea of that is to figure out how many terms there are. There are 9 terms here. Okay, well, the median is essentially splitting something in half, so we want to split 9 in half to find our median. So we take that 9 and divide it by 2, and we actually get something and a half, right? In this case, 4 and a half. Well, that half is going to help a lot because what it's going to tell us is our median is going to be one of the numbers. What it's saying is if we go from our median, we can go 4.5 to the left and 4.5 to the right. Okay, and we want the same whole number amount on each side. Well, those 0.5s kind of represent that one value. And what I mean by that is another way you could always do it is count from the left 1, from the right 1. Left 2, right 2. Left 3, right 3. Left 4, right 4. And then the 5th value happens to be the same for both. And that's what I mean by our 4.5. We've gone 4 this way, and we've gone 4 this way up to this point. And this would be considered the 0.5 of a movement and 0.5 in a movement. In other words, the whole number there. So this is our median value. You've done finding medians before? Mm-hmm. Okay. So now that we have that median value, the next thing we want to do, and this is considered our second quartile, okay, so our Q2 right in the middle, we want to find quartile 1 and 3. Okay, well, we got to figure out how many pieces of data we have to left and right. Well, in this case, I have 1, 2, 3, 4, and I have 1, 2, 3, 4. We're going to have to split those in half. But right away, since we know the number 4 pretty well, that means we're going to have values in between. Right? This way we'll have 2 and 2 and 2 and 2. So in order to find this, we actually find the average of these two values here. And those will kind of be our number. Now the average or the number in between 4 and 5 would be considered what? 4.5. So that's going to be our quartile 1. Okay. So 4.5 splits quartile 1. 6, the value 6 here, is our quartile 2. What comes in between 9 and 11? 10. 10 will be our quartile 3, and obviously at the very end here is our 4th quartile. Okay, so we've split these all into quartiles. And maybe we can even highlight them different colors. Am I able to do that? Yeah, I think I am. So here is our quartile 1. Okay. Then we have quartile 2. Oops. Quartile 3. And finally, quartile 4. Okay, so they've all kind of been split up like that. Oh, I highlighted them. Funny, but does that make sense what we did there? Yeah. So that's how we split up the quartiles. Now the interquartile range, it's usually known as IQR, is actually from Q1 to Q3. This is your IQR, your interquartile range. And to figure out the entire range, specifically that range value, we need the two values of Q1 and Q3. And a range is how far, how many numbers are in between. So what we do to find IQR, we take Q3 and subtract Q1. Okay? In this case, that's 10 subtract 4.5, which means we're going to have 5.5 as our interquartile range. Okay? I'm assuming from there they want your semi-interquartile range. I'm assuming splitting in there. That's a term. We'll talk about that. Range in the following sets of data.
So interquartile is always from Q1 to
Q3. That's your interquartile range. Okay, and eventually you'll get into box plots. I think we've talked about that. And to figure out box plots, essentially that's your interquartile range. This is considered your box. So they'd box the data like this being your Q1 and your Q3. Okay, so all of the data, so the numbers we had like 5, 6, 8, 9, they all fall in the IQR. Okay, and then they have whiskers that kind of come out to our end. And usually what you do with those whiskers is you multiply the IQR, I'm not sure if I'm going to talk about it with you guys, by 1.5. And in this case, that's 5.5 times 1.5. 5.5 times 1.5, so 8.25. Okay, and that's how far the ends of these whiskers go. Okay, so you take your Q1 value, in this case 4.5, and to figure out the end of this whisker, you take that 4.5, and because we're going back, we subtract 8.25. And here we would take Q3, which is 10, and because we're going to the right, we add 8.25, and that will give us the ends of the whiskers. Now, these whiskers are going to be very long, and all of our data is going to fall in it, and that usually helps us find outliers for inner box plots. But I have another whole video on that if you